Hello and welcome to my presentation. My name is Christopher Kopel and I'm happy to have the opportunity of presenting the results of my master's thesis to you. I wrote my thesis at Graz University of Technology in Austria and completed it just a few months ago. And it is about accessible data visualization, in particular how to prepare digital charts in a way that they can be read by blind people. First of all, a short outline of what you may expect during the next minutes. I'll start with an introduction about the chart types we're dealing with, and with an overview of known solutions for presenting charts to blind recipients. Then we'll dig into the main subject of my thesis. I'll introduce two web technologies, namely SVG and ARIA, and explain how they can be combined to create accessible charts. Then I'll tell you about the software I wrote for my thesis and show you a live demo. And in the end, I'll summarize some future work for this project. Okay, so let's start. There are many types of data visualizations, for example, maps, network graphs, flow diagrams, and so on, but we'll focus only on charts of tabular data, that is, charts with data which can be represented in the form of a table as well. And there is an important term you should remember in this context. It is the data point. A cell of such a table or in any data item is called a data point in this context. We'll further focus on two of the most popular charts in the literature, namely bar and line charts. Just to make sure that all of us have the same idea of these charts, a few explanations. A bar and a line chart both have two dimensions, that is, the data points have two components. Let's call them X and Y component. And both chart types also have a two-dimensional Cartesian coordinate system, so an X-Y coordinate system. And within this coordinate system, each data point corresponds to a graphical point, a location, with the X and Y components of the data point. In a bar chart, a data point is shown by a rectangular box, a bar, which starts at on the x-axis and the x coordinate of the data point and ends at the x and y coordinates of the data point. In other words, you can say the y value, the y component of the data point corresponds to the length of the bar. And in a line chart, we have one or more curves where the curve passes all the coordinates, the x and y coordinates of all data points. So here you can say the y component of a data point corresponds to the height of a curve for a given x coordinate. Okay. So how can we present such charts to blind people? As you probably know, there are several ways to do this. First of all, of course, tactile graphics, be it static ones on paper or swirl paper or thermoform method, something like that, and some refreshable dynamic tactile displays, like, for example, the Graffiti by Orbit Research. Then there are acoustic systems, acoustic exploration, either by synthetic speech or sonification, which means non-speech audio sounds. And then there are multimodal systems combining more than one sense together. But there are also special programs running either on a normal personal computer or on a smartphone, which can present the chart objects, the chart components as text fragments. And these text fragments can then be navigated by keyboard and read out by screen reader, either by speech synthesis or in Braille. For example, there are some certain web programming frameworks, so-called charting libraries, which can be used to automatically generate charts from data. And some of these charting libraries also include some accessibility features. For example, the library HiCharts or the library Fusion Charts. When they are used to produce charts, these charts have some features that they can be read by blind users, by screen reader users. So how can this be done? How can a chart be prepared in such a way? The basic idea, the trick behind this, is to define a chart by its semantics and its data rather than its mere visual appearance. So it's not to say, for example, I want an x-axis and I want a horizontal axis and a vertical axis and 3 curves, but to say I'd like a line chart with an x and a y-axis from this in this value range, with 3 data series, 9 data points per series, and these data, or this data table. And the software, if it has accessibility features, then stores this semantic information along with the visual one. So it generates the visual chart and stores together with it in the same data structure this semantic information. And what is also important to mention is that this should be done in a machine readable way. So the information should be stored as text strings so that they can be easily extracted by software without any sophisticated or complex recognition algorithms. And there are several ways to do this, but a recommended way is to use SVG and ARIA. So what's that? SVG stands for Scalable Vector Graphics, and has been standardized by the World Wide Web Consortium, W3C. And it is a format for an XML-based format for storing graphics, which means it stores graphics in a way that they're not composed of pixels, as we know it from JPEG or PNG, for example, but by textual elements enclosed in angled brackets, in less than and greater than characters, as we know it, for example, from HTML. Examples of these elements are a circle, to draw a circle, obviously, or line, to draw a straight line, rect, to draw rectangular box, or path, to draw an arbitrary irregular shape. It has several advantages: less data, lower data amount, and it is machine readable. The graphics are structured as logical objects which are machine readable, and there are also elements for embedding text, plain text, within the graphic. One element is called text. This is to include text which is visible on the screen within the graphic. And there are 2 other elements called title and desc. That's spelled DESC for description. And these elements are meant to embed text for screen readers and other assistive technologies. So they are not automatically rendered on the screen, but they are meant for screen readers. Okay, so moving on to the next technology. ARIA stands for Accessible Rich Internet Applications, and this is a system of text attributes for assigning data and semantics to web content. It has also been standardized by the W3C, in particular by the Web Accessibility Initiative, WAI. That's why it's also called Y-ARIA. And it was originally intended only for web pages and web applications, but it can nowadays also be used for graphics. So how does this work? It's to assign any graphics or any semantics or any other information to, let's say, an HTML or an SVG element. You have to attach a text attribute out of the ARIA set. There are several types of ARIA attributes. The two most important ones for this purpose are the roles and properties. An ARIA role defines the semantics, so that is the meaning of an element. For example, button or checkbox or article. Then there are also properties which add some further information to the object. For example, there is the property ARIA label, which can be used to give an element a name, or ARIA described by, which can be used to point to another element holding a longer description, or ARIA has pop-up says that the element has or invokes a tooltip or a pop-up menu. I'll now show you there are dozens of ARIA roles and properties defined by the W3C for web pages and web apps, but unfortunately there is no standard for charts yet, no standard ARIA roles and properties for charts. However, there are some proposals, some proposed solutions out there on the web. And one task of my master thesis was to summarize these proposals and to combine them to a new solution, where I tried to use as many standard ARIA roles and properties as possible. Some examples of new ARIA roles for charts are the role chart for the chart itself, for the whole chart. Then the role data point, spelled in one word, this time DATAPOINT, to denote a data point, or the role x-axis to denote an x-axis, also spelled in one word, XAXIS. Okay, I'll now show you a short simplified code snippet, SVG code snippet, so that you can see what such a chart might look like. At the beginning you see the SVG root element. It has the role chart to indicate that this is a chart, and the ARIA property ARIA chart type, which is set to bar, so that it says that this is a bar chart. The first child element of the SVG document is a text element with role heading. This says that this is the heading, so the title of the chart. It is set to the value fruit consumption in 2020. So this is the chart title, visible and accessible by screen readers. Afterwards we have a G element. G is for grouping several other SVG elements. In this case it has the role x-axis, so this is the group for the x-axis. It contains all the labels of the x-axis, and it has the property ARIA label set to fruit. So its name is fruit, its x-axis title is fruit. Afterwards we have another G element with the role data set. This is the group which contains all the data points. And as an example, we have within this G group, we have a rect element with role data point. Remember, we have a bar chart, so we need rectangular boxes, and this can be drawn by a rect element. It has role data point, and it has the property ARIA label set to apples. So, and this shall mean that the X component of this data point is apples. And this rect element has another child element. It's a text element with role data value. This is the Y component of the data point, and this has the text content 25. So this data point can be summarized as X component apples, Y component 25, or in other words, the consumption of apples is 25 billions or millions or whatever you may wish. That's up to your fantasy. Okay, so far about SVG and why ARIA. So now let's move on to the practical part of my thesis. It is called the A-Chart software project. A-Chart is spelled capital A, capital C, H-A-R-T. This stands for Accessible Chart, and the project consists of two main software components. The first one is called A-Chart Creator. That's a command line tool for generating SVG charts with the ARIA markup just discussed from tabular data, that is from CSV files. And the second one is A-Chart Interpreter. That's a web application which can be used to open an SVG chart with the discussed ARIA markup. And then it extracts the semantics and the data from the chart and displays them as a textual structure. And this text structure can be navigated by a keyboard and read out by every or any screen reader, or by a built-in speech which is provided by the browser. Okay, so let's have a look at A-Chart Interpreter. Now I've opened up Mozilla Firefox with A-Chart Interpreter and with the chart which we saw in the example previously. You can see on the left-hand side there is the so-called graphic panel where the visible chart can be seen. And on the right-hand side of the screen we have the so-called text panel with the textual analysis. And each object is represented by a textual object which can be navigated either by the virtual cursor of the screen reader, of course, or by the tab key. I'll use the tab key now and move to the first element.
Graphic contains one chart, expanded.
Okay, so it says graphic, that's the root element, the whole graphics document, and says it contains one chart. I'll move on with the tab key.
Chart, fruit consumption in 2020, contains one data series, expanded.
So it says chart and then the chart title and then how many data series it contains.
Bar chart showing amount in relation to fruit, from apples to oranges.
So that's a small, short chart summary, just to know what's going on there. It says the chart type, bar chart, and then it uses the title of the y-axis and the title of the x-axis and says in relation. So it says amount, which is the y-axis title, in relation to fruit, which is the y-axis title, and then it says the range, so the first and the last x value of the x-axis. In this case, from apples to oranges.
X-axis, fruit, contains 5 labels ranging from apples to oranges.
So there we have summary of the x-axis, again with the title of the x-axis, how many labels it contains, and again the first and the last x-axis item. Now the same for the y-axis.
Y-axis, amount, ranging from 4 to 45. Data series, contains 5 items, expanded.
Yes, and now we're on the data series object. It says it contains 5 items, that is 5 data points. And now we move into the data series.
Sort items in original order.
So first of all, we have a drop-down list to say to choose the sorting mode for the data points. The default is in original order, which means as it is visible in the chart.
Apples, 9, 1 of 5.
And now we are within the list of data points, and the first element is apples with y value 9. Okay, that's different from the sample we used before, but no matter. So where there the consumption of apples is 9, and it says item 1 of 5. And now we can step through the data points by the cursor up and down keys.
Bananas, 20, 2 of 5. Grapefruits, 30, 3 of 5. Lemons, 8, 4 of 5.
Okay, and if I now go back to the sorting list.
Sort items in original order.
With Shift and Tab. Now I choose, for example,
from lowest to highest
value. Press Enter and press Tab once again to go back to the list of data points.
Lemons, 8, 4 of 5.
So I'm back on the data point from which I left, lemons. But if I press now cursor down,
Apples, 9, 1 of 5.
it goes up by the Y component.
Oranges, 12, 5 of 5.
Okay. And now there are some features. For example, you can compare the chosen data point to the other ones. This is by opening the context menu for this data point.
Menu, jump to first item, F.
This is, just to jump to the first item of the list. I'll go to...
Shows, compare to the other values of this data series.
And press enter.
C. Leaving menu. Oranges compared to.
Now we have a pop-up window where we see all other data points of this series and a comparison of oranges to this. So let's see.
Close. Lemons, 4 higher, 150%.
So it says oranges is 4 higher than lemons, and that's a relation of 150%.
Apples, 3 higher, 133.33%.
And oranges is 3 higher than apples, that's 133.33%, and so on. I press escape to
Oranges,
go back to the list.
12, 5 of 5.
And what's also available, for example, is statistics of the data series. If I press tab once again.
Show statistics for this data series.
And enter.
Button. Statistics for data series 1.
Now we have some statistical values to get an overview of the data series.
Close. Number of items, 5.
5 items in this list.
Lowest value, 8 for lemons.
So the minimum value.
Highest value, 30 for grapefruits. Range between highest and lowest value, 22.
So the difference between the minimum and maximum Y components.
Sum of all values, 79. Average, 15.8.
Yes, the mean of all Y components.
Median, 12.
And the median, and that's it. I press escape.
Show statistics.
And there is also the possibility to compare a data point to these statistical characteristics. But yes, I think that's it. We don't have so much time, so I'll interrupt at this point. So if you might have seen, the hchart interpreter is online on the web space of my university. So feel free to try it out and yes, have a look at it. It's on www.student.tu.graz, that's spelled TUGRAZ.at/Kopel, spelled KOPEL. And yes, I'm grateful for any suggestions for improvements, any bug reports, any feedback. So yes, feel free to try it out. There's also a help text with a detailed explanation of all features. Yes, apart from this, of course, there are some things which can be done in this project. For example, hchart interpreter should be extended to more chart types and higher chart dimensions. It would be great to have sonification of data series to get an acoustic overview of the data. Then it would also be very helpful to employ intelligent algorithms which compose an automatic description of a chart, an overall description of the data trend. And then one of my plans is to make hchart interpreter a browser extension for Firefox and or Google Chrome, so that you can use it with any arbitrary chart on any arbitrary web page. And finally, another idea is to implement the support for tactile graphic displays, for touch-sensitive tactile displays, so that it reads the finger position of the exploring finger and then reads the information about the touched chart object. Okay, so that's it for my part. I'm happy to answer any questions you might have, and thank you very much for your attention.